Now the old timers, they went at it a little differently. Let's see if I can get this up here. They would do something known as roasting, and I'm sure it's all over eBay or all over YouTube as well, where you start with your lead sulfide, your galena, and your iron sulfide 2, which is your pyrite, and usually in an open frying pan. You get this stuff almost cherry red hot in the presence of oxygen, which is your O2, and that combines to make lead oxide and iron oxide. But all that sulfur combines with oxygen too, and once again it makes that sulfur dioxide. That's very important. Now, once you've got the sulfur dioxide out, it leaves as a gas, leaving you these two, and then you smelt this. So it's a two-step process. First you roast it, then you smelt it. And you smelt it without the lyes, the soda ash, sodium oxide that you get from the lye or the soda ash. But you have to add carbon. Okay, and your carbon can come from something like graphite, charcoal. A lot of the old timers use flour or sawdust, which just burns up and leaves you carbon. So the reaction here is that our lead and oxygen, or our lead oxide, plus the carbon will perform pure lead as the oxygen and the carbon combine to make CO2, which leaves once again as a gas, and our lead will just settle to the bottom of the pot. The iron oxide, though, it would need just an insane amount of energy that we're not going to be able to give it to get it to strip off that oxygen as carbon. So this doesn't react, and this iron oxide is absorbed into our borax and silicon slag. Once again, we have no soda ash or lye in this one, so that's just straight up absorbed. Which brings us to the next big thing that I want to bring your attention to, and that is that sulfur dioxide that we either got as a product of our roast, or if you smelted with oxygen, which you shouldn't be able to if you're using a flux. If you take 2 sulfur dioxides and add a little bit of oxygen, which would happen in a smelt, then you would end up with 2 sulfur trioxides, SO3, not SO2. The SO3, if it ever gets in contact with water, becomes H2SO4, and that is sulfuric acid. So what's important to note is this is a gas. This is water, just like you find in your lungs. So what I'm trying to say is if you breathe this gas in, you're making sulfuric acid inside your lungs. I caught just the slightest whiff of it, and man did I regret it ever. So that is not in the slightest bit cool. So how do you get around that problem? This is a 3M breathing mask. Now this particular mask is equipped with these P100 filters. Now if you go on just about anywhere on the internet, they'll tell you that if you're going to be smelting, you need a P100. If you're going to be smelting lead, you need a P100, and they're right, and they're very, very wrong. The reason is you run into something here with the way that this is managed as far as the standards. P100 is particulate filter, and this mask is a particulate filter. It would filter out dust, it would filter out the lead particles that come naturally in the air when you smelt lead, and that's it. Just solid particles, that's all it does. There's also a P95, which is a lesser standard, doesn't filter out as much. You don't want a P95, you want a P100. But what almost nobody ever mentions is that there's more to it than that. Now there's a P100 OV. OV stands for organic vapor, and that would be things like gasoline, solvents, paint thinners. If you were burning oil off in your smelt, this would filter out the OV, and I believe they do that with a activated charcoal inside the filter. The second thing you run into is a P100 AG, and AG stands for acid gas. That's acid gas. This is exactly what this filter is designed for, is for particulates and acid gas, and this is something that you need if you're going to do this process. The last filter is just basically a combination of these two, where you get the P100, organic vapor, and acid gas, and I have one right here, and that is a part number 60926 3M. And if I read right off the back of the package here, it will say NIOSH approved for use against certain organic vapors, sulfur dioxide, hydrogen chloride, chlorine, ammonia, methylene, formaldehyde, or chlorine dioxide, or hydrogen fluoride, or hydrogen sulfide, all nasty stuff, and particulates. This particular package does not say OVAG, it says multi-gas. So if you find one that you like, and I bought this at my local hardware store, flip it over and read what it's for. But you need that acid gas for sure. The organic vapor would be nice. This plain P100 with an acid gas, that's kind of a difficult one to find because it's just as easy to throw in the OV as well and sell one filter that fits everything. And then that leaves me with my last thing I was going to say, not really pertaining to safety so much, but if we look at this reaction here that comes in two sections, where you roast it, which is bad because of the gas, and then where you work it back with carbon. If you have just an iron oxide, and for this I'm going to say black sand, hematite and magnetite are both just iron oxide, and you smelt the iron oxide, black sands, and say you've got gold from a river with a little bit of iron, a little bit of gold and a lot of black sand, you smelt it, all you need is borax and the silicon to make your flux, and that will absorb your iron oxide, your black sand, and leave your gold behind. Now you will also need a little bit of a collector metal just because the gold amount will be so small, which is another story for another day. But I think that covers how to, or at least the chemistry behind sulfide smelting, what not to do sulfide smelting, and what to protect yourself from when you're sulfide smelting. All very important things. So that should be it, and thank you.